Okay, my AS or A2 math students, in this question we are told or given that the polynomial p of x or p of x is given by p of x is equal to x cubed plus x squared minus 10x plus 8. AI, using the factor theorem, show that x minus 2 is a factor of p of x. So remember, the factor theorem says if x minus a is a factor, okay, that means f of a, so subbing in x equals a, must be equal to 0. So if x minus 2 is a factor, that means x equals 2 is a solution, right? We have to now show that when we sub in p of 2, we get 0, okay, or it's equal to 0. So our job is to prove that p of 2, okay, when we sub in x is 2, we get 0. So we're going to have what? Let's do it here actually, so we've got a bit more space. So p of 2, okay, just so you can see my full workings, is equal to 2 cubed plus 2 squared minus 10 lots of 2, so 10 times 2, and then plus 8. So let's obviously work it out, yeah, but yeah, on our calculator if we need to. 2 cubed is 8, 2 squared is 4, 10 times 2 is 20, so minus 20, and then plus 8, and then working from left to right, okay, so then let me just get my calculator to obviously prove this. 8 plus 4 is 12, minus 20 is minus 8, plus 8, and we get 0, yes, okay, so this becomes 12, 12 minus 20 is minus 8, and then minus 8 plus 8 is 0, but this is equal to 0, therefore x equals 2 is a root or a solution, okay, and thereby x minus 2 is a factor. Sorry guys, yeah, about my lack of space, and I apologize. So, and x minus 2 is a factor, okay, so you use that pot there, okay, is a factor, okay. Next up, part I or double I, hence express p of x as the product of 3 linear factors. So here I'm going to use the grid method here for log division. Okay, so let me just get some space now. So let me just delete this part here so I've got a bit more space. Okay. So let's just draw out our little grid. Okay. So we're going to have x minus 2. Then we're going to have x cubed in here. Okay. X is into x cubed, go x squared times. Then I do x squared times minus 2 is minus 2x squared. But hold up, guys. We want plus x squared. So to make it plus x squared, we'll have to put a plus 3x squared here. So we're always looking at our leading diagonals for when we're collecting like terms. Okay. So looking at our leading diagonals, okay, for that. X is into 3x squared, go 3x lots of times, or 3x times. And the 3x times minus 2 is minus 6x. But again, we want minus 10x. So to make it minus 10x, I have to put a minus 4 here, because when you combine minus 6x and minus 4, you get minus 10. X is into minus 4x, go minus 4 times, and minus 4 times minus 2 is positive 8, which is what we want there. So we can stop there, okay, and say that, yeah, our quadratic that we get is x squared plus 3x minus 4, okay, when we multiply that by x minus 2, we get p of x, okay, or the function px, or p of x, okay. I'm now going to factorize this quadratic here, so it's nice and easy. So it's going to be double bracket, okay, so x and x go in both. Two numbers that add to make plus 3, and the same two numbers that multiply to make minus 4, or negative 4. That'll be plus 4 and minus 1, or minus 1 and plus 4. Okay, is equal to p of x. That's part II now complete, okay? So we get x plus 4 times x minus 1 times x minus 2, okay? And that is a product of 3 linear factors, okay? So if you're wondering, yeah, my roots will obviously be minus 4, 1 and 2, okay? For that, okay? Next up, part B. It says sketch the curve with equation y is equal to x cubed plus x squared minus 10x plus 8, showing the coordinates of the points where the curve cuts the axes, okay? In brackets, you are not required to calculate the stationary points, so that makes it obviously easier. So again, it's a rough sketch. It's not going to be perfect. Okay, it's a positive x cubed, to be clear. The roots will be minus 4, 1 and 2, and it's going to look something like that. Okay, let me just delete here so I've got a bit more space. Oh. So we've got minus 4, 1 and 2, and again, forgive me here, it's not obviously drawn to accuracy, so I apologise, and it crosses the y-axis at plus 8. So the y-axis is when x is equal to 0, the x-axis is when y is equal to 0, okay, or p of x is equal to 0, okay, and that is what the positive, okay, cubic shape. If it was a negative, it looked a bit different, it would look something like this, okay. It was a negative cubic here, or a coefficient here, that was obviously negative, but because here is actually positive x cubed, okay, it's like a little, yeah, like S shape on its side, okay, looking like that, and then they would obviously be your roots of minus 4 or negative 4, 1 and 2, and the y-axis would be crossing at 8. Okay. Sometimes, yeah, it's probably easier to just like draw like the curve first, yeah, then put your crosses and then add the axes to it, okay? If you find it hard to obviously sketch it, because occasionally on the screen, personally, yeah, I find it hard. Obviously on paper, I find it much easier, but on the screen, I find it a bit harder, although on paper, yes, it's not much different. But if you find it harder, maybe like draw the shape of the curve first, okay, and then put your point of like intersection, and then adapt your x and y axes, okay, according to your drawing, like this, okay. And that is working with a cubic.